Greetings and welcome to another installment of Easy SPSS. I'm Dr. Gross, and today we will cover McNemar's test, just a revisitation of our data set. Wherever you have it saved, you would access it via that tab, open folder, and two basic views, data and variable view. In data view, our rows represent participants, columns represent variables. And in variable view, our rows then are our variables, and our columns then are characteristics or parameters of those variables. And so we're up to right here. We added a post-exercise program weight last time. And today for this test, we're going to need two kind of binary variables, right? It's either a yes or a no kind of a thing. Did they lose weight in the first part, or did they not lose weight? Yes or no? And so that kind of makes this categorical data, right? It's a yes or a no. They fall into categories, and so this is nominal. Another reason for McNemar's test. So let's go ahead and work from the script, and we'll add these variables and we'll run the test. So what is it? It tests whether the proportion of participants losing weight changed from the beginning to the middle versus the middle to the end. So it kind of splits the time period into two, right? So was there a difference in the way participants lost weight in the beginning versus the end? If you wanted to put it that way, or from this period to this period versus this period to this period, right? Again, it's going to work well because we have this type of categorical data. Yes, no, did they lose the weight? And so we will add two variables today. We're going to add what I titled a base mid underscore. So base to mid loss flag. So the flag is either it's a 0 or a 1. You know, that's the one is the flag. If they lost, it's a 1. If they didn't, it's a 0. And then a mid to post or mid underscore post loss flag. So again, we'll code that as 0 for no loss and a 1 for yes, they lost weight. So let's add those things in. So we'll go to variable view. Yeah, get out of there. Which we're in. And the next available one you should have is 14. And so we'll use 14 in row 15. So in row 14, go ahead and write in mid underscore post loss flag. And then for let's go ahead and do both at the same time. For row 15, go ahead and type in base underscore mid loss flag. And I'm just gonna scroll over slow. You can pause here if you'd like, but I'm gonna scroll slow. The type for both are numeric. Remember, we're on row 14 and 15. The width is fine. That'll auto-generate itself. Decimals, you don't need them. For the labels, right? Again, we're here at row 14 and 15. Right? Baseline to mid, and then mid to post, right? And so I added some labels for that, and I could have done a better job. So if you notice, like, it would have been nice if I put mid to post and then base to mid as my labels. So I'm going to go ahead and change that. And then that kind of makes our output easier to read. So again, like I can't even remember which one was which. Mid to post for 14. So I'm going to add that in. This is weight loss flag, and it's mid underscore to post. And I forgot my close parentheses on that too. And then this one was base to mid. So I'll go over to my label and let's add that in. This one was base weight. to mid weight. Let's close that parentheses. Okay. And so now I have my two names for my variables, mid to post and then base to mid. I suppose that's kind of out of order. Would make more logical sense to have base to mid and then mid to post, but it'll be okay. So again, I added in that it's valuable when you get the output, you can read it a little bit more easily. And then I went ahead and also put in what the values mean. So 1 is yes, they did lose weight, and 0 is no, there was no loss. But I need to tell SPSS that. So then I'm going to go into values. And for this, I could reset it and it would empty it out, but you're just going to hit the plus twice and it will give you 2 rows, right? So if I hit plus, it'll give me a new row. So you'll hit plus twice, and then in this cell, you'll type 0 in this one. And the 0 means no, there was no weight lost. And then the 1 means yes, there was weight lost. And you would do that for variable 15, right? The same thing here is, did they lose weight or not? And we're going to use the same code. 0, no. No weight lost. 1, yes, they lost weight. And again, I would hit my plus a couple of times to get those cells or rows to generate. In this case, I did have, 2 participants. If we go back up here to weight, I did have 2 participants who had some missing values originally in the data set. And so for that, I had to code them as negative 99, and negative 99 indicated that was missing data and SPSS should not include it. And also had that for 2 participants for their height, I believe. So since we were comparing their base weight, which was this weight, to the mid weight, which we created, I was unable to calculate that, right? Because there was no base weight to compare it to. So for those cases, I put my missing value code of negative 99, and I'll show you that in just a second. So now that we have most of this done, we'll finish up by just labeling these as nominal for their measure. Now I want to go back to data view. I'm going to scroll over and you can see those 2 variables that we just generated. And, if I value label it, you can see what those codes mean, right? The 0s are no loss, and then the 1s are, yes, lost weight, all right? And so how you would do this is, or how I did it is, I looked at, okay, from the mid to the post weight, did they lose weight? 152 to 153? No, they gained weight, so it's a 0. So I looked at all those rows and manually put those in. I encourage you to pause and just type this in, and that will save you a lot of time. Same process for base to mid. I looked at the base weight over here and then compared it to the mid weight. And did they lose 128 to 150? No, they gained weight. So 0, no weight lost. These were the participants 11 and 12 where I did not have an original weight. And you can see that for the weight for 11 and 12, right? I did not have a weight for them, an original weight. We also didn't have an original height, or an original height. They might have changed height since then. This is all hypothetical. Anything could have happened. And so since I didn't have a base weight to compare it to, again, I coded these as missing. And in variable view, if I go back, I have noted that the base to mid loss flag variable that we're doing right now, I noted that there were some missing variables. And so how I told SPSS to tell if there's missing variables is like I go to that variable in variable view and I go to the missing column and I say, okay, for yes, for a discrete missing value, I want -99 to represent a missing value. And then click OK. And now SPSS will recognize a -99 input as a missing value and not try to analyze it. Ooh. Let me go back to my data view one more time. And then if you need to pause right here to input these, go right ahead. All right. Excuse me, sorry. So we've added the encoded the flags or the flag variables. Basically, it's just it's binaries, yes or no. The flag is the one, you know, if you want to interpret it that way. If you wonder why I keep saying flag, using that term. Right. So there is another way to do that. There is a compute variable function. If you're not familiar with that, I would just, again, do the pause and copy thing. So let's run the test. So we'll go to Analyze and Descriptives this time. And then we'll go over to Crosstabs. And now I already have them in here, so let me take them out. And what we want to do is we want to move mid post loss flag into the row or the target list, and then the base mid loss flag into the column. So this is our, and this appears because we added that label, which is helpful. Let's just display variable names. Okay, so let's move the mid post loss flag right here into the target list. And then let's move the base mid loss flag, base to mid program flag to the column. We're going to click on stats and make sure McNemar's is checked. I say McNemar, oh, you know, it's probably McNemar. I'm not sure, but continue now that it's checked. Sorry, I'm being so silly during this video today. Now that's done, we can click OK. And let's take a look at this output and try to recreate it over here for you. So this is the 2x2, right? So the crosstab or the cross tabulation. And if you're not familiar with reading these, it can be kind of confusing sometimes. Basically, what you're trying to do is you're trying to say, are there more people who ended up losing weight in a period of time, and we have 2 periods of time, base to mid and mid to post, versus the other, right? Versus the other way around. You know, are there more people who lost weight versus more people who gained weight? This is kind of how you can look at this. So let's look at this table, all right? And I'm going to explain it cell by cell. All right, so top left right here, no to no, right? So 0 to 0, right? That equals 9. So that's saying 9 participants did not lose weight in the first half, and they didn't lose weight in the second half. So base to mid and then mid to post, right? Right here, this is row 0, right? So 0 was no loss. And then column 1, which was yes. So that's 1. So 1 participant did lose weight in the first half, but then did not lose weight in the second half. in the bottom left, right here. So row 1, which means yes, and then column 0, which means no. It's 8, right? The value is 8. So what that's saying is 8 participants did not lose weight in the first half, but they did lose weight in the second half. And then this last one, 12. All right, so 1 and 1. 12 participants lost weight in both intervals, is how you would interpret that. So moving on, how do you really spot the change? You want to look at the diagonal, the status change, right? So from how many people went from no to yes versus how many people went from yes to no, right? And so McNemar's test checks whether those two numbers, 8 to 1, are significantly different. And you would check that diagonal, right? So yes to no is right here. And then no to yes is right here, right? So those flip-flops that we're trying to check, right? That is an 8 to 1, right? It's checking whether those are significantly different. 8 to 1 seems significantly different to me, just looking at it, but we'll see. And so now you want to go to your last piece of output, the actual test. So you have a 0.039 level of significance, or p-value. So that indicates a statistically significant swing or change. So out of the 30, right, out of the 30 valid participants that were used, 8 went from no loss in the first half to losing weight in the second half, but only 1 went the other way, losing weight to gaining weight. So that is a statistically significant difference. Another way to kind of say that, so because 8 people switched from no loss to losing weight, while only 1 went the other way, the data show a clear shift toward more people losing weight in the second interval. That imbalance is what the significant McNemar p-value is saying, is that since this is significant, this change or this swing is not just is our confidence that it's not due to chance is very strong, right? So we can say this is a significant change that's not just due to random chance, or at least we're very confident. Another way to say it is that significantly more people lost weight in the second half of the program, so from the mid to the post, as opposed to at the beginning of the program. So again, you might not have the same data that you're working with if you ever attempt this test again. But if you're ever in a situation where you do have categorical data and you're trying to see, is one significantly different from the other, as far as kind of this binary yes versus no flag data, then McNemar's test is a good one. I hope that was helpful, at least in how to run and interpret the output for this test. So this is Dr. Gross signing off. Hope to see you next time.